In this lesson, we're going to look at how we can find the limits of a function given its graph. Let's take a look at this graph right here. Now, we've seen in our introductory video on limits that limits can help us study the behavior of a function at the values of x where an image cannot be found, such as restricted values of the domain and the infinite bounds of the domain. Looking at this graph right here, we can see a restricted value at x equals to 0, a restricted value at x equals to 3, and of course we have the infinite bounds, one at negative infinity and the other one at positive infinity. So for this function right here, we have 4 limits to evaluate. One at negative infinity, one at positive infinity, one at 0, and one at 3. Starting with the limit at negative infinity. As x moves towards negative infinity, we can in fact see the curve move infinitely in the same direction, but limited by the line y equals to negative 2. So at negative infinity, the function has a y value of negative 2. So we can in fact say that the limit when x is approaching negative infinity of f of x is equal to negative 2. Now let's look at the limit when x is approaching positive infinity. As x goes infinitely towards positive infinity, we can in fact see the curve infinitely moving downwards. Downwards, which corresponds to the values of y moving infinitely downwards towards negative infinity. So when x approaches positive infinity, y is moving towards negative infinity. So we can say that the limit when x is approaching positive infinity of f of x is equal to negative infinity. Now let's look at one of the restricted values, which is x equals to 0. So to find the limit when x is approaching 0 of f of x, we've seen in our introductory video on limits that whenever x is approaching a finite point, we can basically approach that point either from the left or from the right. So over here, in order to find the limit when x is approaching 0 of f of x, I need to find 2 limits, one to the left of 0 and one to the right of 0. So we can see to the left of 0, which means that y is moving towards positive infinity immediately to the left of 0. Now similarly, to the right side of 0, we can see that the curve is moving infinitely downwards. So y is going towards negative infinity immediately to the right of x equals to 0. So the limit to left of 0 is positive infinity, and the limit of f of x to the right side of 0 is negative infinity. The limit to left and the limit to right of 0 being different, then we can say that the limit when x is approaching 0 of f of x does not exist. Now let's look at the limit when x is approaching 3 of f of x. In order to make sense of the left and right of x equals to 3, let us draw the vertical line at x equals to 3. So again, we need to look at the limit to left of 3 and the limit to right of 3 of f of x. Now for the limit to left, immediately to the left of x equals to 3 on the curve corresponding to f of x, we can see a point where the y value is in fact equals to negative 1. So the limit to the left of 3 of f of x is equal to negative 1. Now to the right of x equals to 3. If I were to plot the point on the curve immediately to the right of x equals to 3, I can see that I also have a point with the same y value equal to negative 1. So the limit when x is approaching 3 plus of f of x is equal to negative 1. So the limit to the left of 3 and the limit to the right of 3 of f of x are both equal to negative 1, then the limit at x equal to 3 exists and is equal to them, which means it's also equal to -1. So now we have seen how we can find the limits on a graph looking specifically at restricted values and the infinite bounds. In our next lesson, we're going to look at how we can find the limits of a function algebraically using only its equation.